intro.
Okay, so dito sa ating part 3, so I think this is the last part do sa ating introduction about the structural theory or structural analysis. So this time we will now define the classification of structure. So what are the general classifications? So una, you have what we call the tension structures. Then we have also the compression structures. Next, we have the trusses. So, siguro alam mo itong mga trusses. Next, we have the shear structures. And last, we have these bending structures. Okay, so ano ba yung mga tension structures na tinatawag? So, these members, so siguro may idea kayo kung ano yung normally na under tension, no? So, yan yung mga cable, no? So, ayun. So, tension members are structures subjected to pure tension under the action of external loads. Because the tensile stress is distributed uniformly over the cross-sectional area as a member, the material of such as structure is utilized in the most efficient manner. Okay, so highlighted here, so tension members composed of flexible steel cables are frequently employed to support bridges and long-span roads. So, merong asing suspension bridge na tinatawag kung saan gumagamit tayo ng cables. And the force on the cable is under tension. So, ano naman yan? Meron naman tayo ditong topic sa structural theory na pag-aaralan natin yung cables and arches. Okay, because of their flexibility, cables have negligible bending stiffness and can develop only tension. Thus, under external loads, a cable adopts a shape that enables it to support the load of tensile forces alone. In other words, the shape of a cable changes as the load acting on it changes. Tingnan natin ang isang example ng tension structure. So again, this is a example of suspension bridge. Kung saan yung mga typical parts niya. So, we have here the main cable, itong nasa gitna. And then, the cable anchorage, yung anchor niya, o yung pinaka-angkla, o yung nag-act as a support. So, ito yung nakikita kayo nito. I know. And then, we have the hangers, itong mga vertical members. So, ito yung nag-support mismo doon sa mismong bridge, yung mahawak sa kanya. Okay, next. So, let's proceed with the compression members. So, compression, as for the term itself, compressive force yung dinadala niya. So, one example of this is the column, poste. So, under tensile stress. Under compressive stress. So, nagkaaroon nga tayo ng nagbabakal because of this compressive force. So, compression structures develop mainly compressive stresses under the action of external loads. Two common examples of such structures are column and the arches. The columns are straight members subjected to actually compressive loads, when a straight member is subjected to lateral loads or moment in addition to actual loads. It is called a beam column. Next, proceed dun sa ating next example ng compression structure, we have the arch. So, ang arch, so kung makikita mo yung mga hallway, yung mga pinto, yung mga naka-arko dun, So, later on, pag na-discuss natin yung topic na cable and arches, ipapakita ko sa inyo yung itsura ng arch. Pero ito yung mga shape na nakaganan, naka-U. Inverted U. So this is a curved structure with a shape similar to that of an inverted cable. So di ba ang cable mo, naka-U lang siya, ganyan. Ang kabaligtaran lang kay arch, naka inverted U siya. Pag ganun. Such structure are frequently used to support bridges and along-span roofs. So the arches develops mainly compressive stresses when subjected to loads and are usually designed so that they will develop only compression under a major design loading. However, because arches are rigid and cannot change their shape as can cable, other loading conditions usually produce secondary bending and shear stresses in these structures. So under arch pala, nagkakaroon ka ng bending and shear stresses, which, if significant, should be considered in their design. Last, because compression structures are susceptible to buckling or instability, the possibility of such a failure should be considered in their design. If necessary, adequate bracing must be provided to avoid such failure. So ito kasi susceptible dito sa mga failure under buckling and yung bending and shear stresses. That's why if you're going to use an arch in your structure, it's better to put adequate bracing to avoid such failures. Pagas na. Next, we have the truss structure. So what are trusses? So ito naman is na-discuss na natin before sa static of rigid bodies. So ano nga yung dalawang ways of computing truss problems? Ito sa theory of structures, meron tayong di-discuss na other type of truss, yung complex truss. Medyo mahaba ang solusyon nito, parang inulit mo ng 2 beses and magkamali ka ng isa, so damay-damay na lahat. Very tricky, madali lang yung computation but medyo mahaba talaga. So medyo ano lang siya sa prone sa mistakes and errors, lalo na pag nagpipindot. Naalala ko before, yung complex truss, hindi ko talaga siya naitama. Pero alam ko alam ko yung gagawin ko. Yung mga simpleng bagay talaga yung napagkakamalian. Which makes this topic, complex truss, very, very, very interesting. So trusses are composed of straight members connected at their ends by hinge connection to form a stable configuration. When the loads are applied to a truss only at the joints. So maalala before, di ba lagi lang siyang nando sa mga joint, sa dugsungan. It member either elongate or shortens. So if under tension ka, ang member mo will have a tendency to elongate, and if kapag compression, that will makes the member shorten. Review lang. Thus, the members of an ideal truss are always either in uniform tension or in uniform compression. Real trusses are usually constructed by connecting members to gusset plates by bolted or welded connection. So upon the pagdating niya ng next, I don't know if next sem or next year, so dyan papasok yung structural steel design. So mag-design na kayo dyan ng gusset plate and bolted or welded connection. I-design nyo kung ilang bolts, kung gaano kahaba yung weld na kailangan yan, no? So wag kayo masyado ma-excite, ituturo rin sa inyo yan later on ni Sir Jake. Although the rigid joint does cause some bending in the member, soft truss, when it is loaded, in most cases, such secondary bending stresses are small and the assumption of hinge joint yield satisfactory design. Okay, so tingnan natin yung mga itsura ng truss. So normally nakikita mo siya doon sa mga bubong, diba? Sa long span roofing. At the same time, makikita mo rin siya sa mga bridges. So roof frames are made of truss because of its lightweight properties. Okay? And di ba normally ang shape ng iyon truss dapat nakakabuo ka ng triangle shape. So I believe meron akong video nito sa mga ano natin previous discussion do sa I don't know if it's SRB or deformable. Pero pinaliwanag doon kung bakit yung triangle yung pinaka efficient shape. Okay? So the member of the truss are connected to the gusset plate or grouped by bolts. So ito yung mga bolts, no, yung mga bilog-bilog na yan. Yung malaking bolt and nuts. Hindi mo nang problema yan. Sa ano na yan. So, shear structure. So, ayan na naman. Meron na naman tayo isang napakahabang word dito. Tingnan tayo pinamahabang word sa dictionary. So, shear structure. Shear structures such are reinforced concrete shear wall. So, ito yung shear wall na tinatawag. Ano? Most commonly ito makikita nyo sa mga elevator shaft or doon sa malalapit sa staircase. So, itong mga shear wall na to, if magkaaroon ka ng lindol, ito yung pinaka-matibay na part ng isang building. So, mas maganda dito kayo dumiretso. Ano? So, kung makikita nyo minsan sa mga gumuguhong building, minsan yung mga hagdan nakatayo pa. Okay, so are used in multi-story building, lateral movement due to wind load and earthquake excitation. Shear structures develop mainly in plane shear with relatively small bending stress under the action of external loads. So, kung maalala yung shear, di ba? Ano ba yung shear? Shear yung pag-iis-isan. So, with that, na-design itong iyong reinforcement na to. So, I think tuturuan din nga mag-design ng mga shear structure sa inyong RCD, reinforced concrete design. Okay, sa bending structure, mga biga, slab, plates, and rigid frames. So, bending structure develop mainly bending stresses. Bending stress or flexural stress under the action of external loads. In some structure, the shear stresses develop associated with the changes in bending moments may also be significant and should be considered in their design. So, kung maalala nyo yung sa deformable bodies natin, yung design considering the shear stress and the bending stress. Yung MC over I and BQ over IB. Ano, so minsan ipapahanap sa yung allowable load na kaya lang i-carry nun or yung magiging size ng iyong beam, etc. So these are the different types of bending structures. So namely, beams, rigid frames, slabs, and plates and shells. So sa sunod na slide, ipapakita yung mga different bending structure. So we have here the beam. So a straight member that is loaded perpendicular to its longitudinal axis. So sometimes beams, meron pa tayong isang type ng beams which is the girder. So ang girder siya yung may hawak doon sa beam. So this was already discussed before. Ano? Rigid frame composed of straight members connected together either by rigid or moment resisting connection or by hinge connection to form stable configurations. So mga warehouse long span roof, so kailangan ng rigid frames. Okay, so last, so these analytical models. So what do we mean by analytical model? So this is a simplified representation of a real structure for the purpose of analysis. Development of the model generally involves, so number one, determination of whether or not the structure can be treated as a plane structure. Number two, construction of the line diagram of the structure. Number 3, idealization of the connection. And 4, idealization of the supports. So, tuturuan kayong gumawa ng analytical model. So, example nito is when you design frames, yung mga connection niya between all members. Makikita mo rin dun yun, yung mga forces or the internal forces acting at the connection, yung mga moment, etc. So, ito naman discuss later on sa mga susunod na discussion. So that ends our video, and for our reference, Sir Dick used the book Structural Analysis by Casimari, 5th edition, from pages 3 to 16. So this is the content source. Okay, so that ends our video, guys. If hindi pa nakasubscribe, please subscribe to my YouTube channel as part of your support and effort na paggawa ko ng video tutorial. And if you have some comments, don't forget to leave a comment on the comment section below. Peace out.